Welcome back to Pro Educator. Today's lesson will be on an introduction to logarithms. Before we get into logarithms, let's do a quick review of the laws of exponents. The product rule states that if you're multiplying two powers with the same base, you can add the exponents. So I've written x to the a times x to the b. We can simplify this to be x to the a plus b. The quotient rule states that if you're dividing two powers with the same base, you can subtract the exponents. So we can say x to the a over x to the b equals x to the a minus b. The power rule states that if you're taking a power to a power, you multiply the exponents. So if we're taking x to the a to the b power, we can write it as x to the a times b power. Let's define what a logarithm is. Logarithms are basically the inverse operation of exponents, taking a power of something. So it's like addition and subtraction. Addition and subtraction are inverses of each other. Multiplication and division are inverses of each other. Taking a power of something and taking the logarithm of something is the inverse of each other. So when you're writing logarithms, we tend to abbreviate the word logarithm into log. So log base a of y equals x. That's how you're supposed to say it. Or logarithm of y with base a equals x. And we all know how to say an exponent, y equals a to the x power, or y equals a to the x. Now let's go ahead and take a look at what the y, a, and x actually mean in a logarithm. So the a is the base of both logarithmic expression and an exponential expression. So a is the base. Y in a logarithmic expression is the thing being taken of the logarithm. And in the exponential expression, it is the result. The x is the result of the logarithm and the exponent of the exponential expression. Remembering what these mean are pretty necessary. They're absolutely necessary, actually, to being able to convert between exponential and logarithmic forms. These two expressions say the exact same thing because it's just how it is. These two just say the exact same thing. There's nothing else to it. A is the base in both of them. Y is the thing being taken of the logarithm, and the base, the result of the exponential, and the x is the exponent and the exponential, and the result of the logarithmic. So let's do some practice problems, and I've already written both of them in MindPad. So first one is log base a of 4 equals 3. We're going to convert that to exponential form. So log base a of 4 equals 3. So let's go ahead and identify the three main parts of a logarithm. So base is 3. The result is, I made a mistake. The base of the logarithm is a. The result of the logarithm is 3. And the thing being taken is 4. So I'll just write thing being taken. TBT. That's a horrible beat. Thing being taken. We'll just write that as 4. So the base of the logarithm is the base of an exponential. So we can just write a. The result of the logarithm is the exponent of the exponential. So we can write 3 here. And the thing being taken is the result of the exponential. So we can write this as 4. So here is our exponential expression. Now, like I said before, these two expressions mean the exact same thing. This one and the one above here. These two say the exact same thing. So let's go ahead and do another example, which I written right here. Let's convert 2 to the x equals 5 into logarithmic form. 2 to the x equals 5, and we're going to convert this into logarithmic form. So let's go ahead and write base exponent and result. So the base of this logarithm is, exponent is 2. So is 2. The exponent of this exponential expression, as we can see, is x. The result of this exponential expression is 5. So let's go ahead and convert this to logarithmic form. So the base of the exponential is the same for logarithmic. So log, we can write base 2 as a subscript. Then we write the exponent as the result of the logarithm. And the result of the exponential is the thing being taken of the logarithm. So we write that here. And we have successfully taken the exponential expression and turned it into a logarithm. Now, there are two main types of logarithms that you should know, special types. This is the base 10 logarithm and the natural logarithm. Now, these two logarithms are very special because we see them a lot in mathematics. The base 10 logarithm is basically a logarithm with base 10. So this is the base 10 logarithm. And usually we omit the 10, so this becomes log x equals y. And if we were to convert this to exponential form, this would be 10 to the y equals x, because the base is 10, the result is the exponent, so it's y is the exponent, and the thing being taken is the result of the exponent. So we usually omit the 10. So this is usually how you'll see natural logarithms, base 10 logarithms. So always remember, base 10 log x. So let's go ahead and talk about natural logarithms. So natural logarithms are basically logarithms with the base e. So basically just base e logarithms. E is Euler's number. He's a very famous mathematician. He is known as the father of Euclidean geometry, just the father of geometry in general, and he was able to figure out what this number approximates to. And we usually just say 2.718, and it's irrational, so it keeps on going forever and ever. It's like pi. So when we base e logarithm would look like this: log base e of 5, and at something, we'll just call that y. We write this differently, like how we write base 10 logarithms differently. We write base e logarithms differently. We write them with an ln, so it's written as ln of 5 equals y. Now, this is how you'll see it in most textbooks. Mathematics professors write them like this. This is how you'll see them most of the time. So, natural log is written as ln of x equals something 5. I'll just leave it that. So that's it for this lesson, guys. Hope you enjoyed this lesson. Please make sure to like, subscribe, and comment.